Welcome back students to our geometry class, chapter 4, practice set 4.2. Let's begin with 4.2 exercise, and in this practice set we are going to study to construct the tangents. Okay, and there are three ways in which we can construct the tangents to the circle. The first method here is we have to construct the tangent to the circle using the center of the circle. The second method is you are going to draw or construct the tangent to a circle without using the center of the circle. And the third here is we are going to construct the tangents to a circle from a point outside the circle. So in this third type, we are going to construct two tangents to a circle, okay, from a point outside it. Now we have studied the properties about the circle and the tangent in this chapter, circle. So a few properties from there we are going to use in order to construct the tangent to a circle. Okay, so let's begin. Now in this first sum we can see here, if you read, construct a tangent to a circle with the center P and radius 3.2 centimeter at any point M on it. So there is a circle with center P. Then the radius what we are going to use here to draw the circle is 3.2 centimeter, and we have to take a point M on the circle anyway. Okay, and the tangent should pass through that point M. Okay, so let's begin. So as I told you in the earlier practice set 4.1 also, so before we begin with the construction, the actual construction, we should have our rough figure or the analytical figure. Okay, so this analytical figure I have already drawn for you all. The circle I have taken, so this need not be the exact measure. Okay, so this is a circle where the radius I have shown here 3.2 centimeter. The center I have shown as P. Then I have taken this point M on the circle. Okay, and I have shown you can see here I have shown a tangent which is passing through this point M. Okay, now here this property what we are going to use is, that is the radius and the tangent are perpendicular to each other, which we have already studied in chapter 3. Okay, so if I draw or if we construct a perpendicular which is passing through point M, okay, the PM is a radius, and if we draw a perpendicular which is passing through that M, it becomes the tangent, because as I just told you that we have studied this property that the radius and the tangent are perpendicular to each other. Okay, so now I've taken this compass, and you need a scale so that we can adjust this compass, that is 3.2 centimeter, in order to draw the circle. Okay, so I've taken 3.2. I'm going to draw a circle here. Okay, now I mark the center which is point P. Okay, then I will just show the radius here. Now what I do is I draw this radius. So this becomes this point M which is on the circle, and I extend this radius a little outside so that it will help me to draw the perpendicular. Okay, so usually when we are doing this, try to take the point on the right hand side. Okay, so it becomes easier. You can take this point anywhere, at the top, bottom, left hand side, anyway. Okay, but preferably you can keep it on the right hand side so that you can use the compass very easily. Otherwise you have to turn the page and do it, or even that is okay if you take it up, down, anywhere on the circle. So now what I'm going to do is, I'm going to take the compass again, and I'm going to draw a simple perpendicular passing through the point M. And this you have already studied in the earlier standards, that how to draw a perpendicular passing through a point. Now since I want a perpendicular to pass through this point M, I'll take the compass and the pointer I will place on point M. Okay, this can be any distance. Okay, don't keep it very big. Don't keep it very less. Okay, so a medium distance you can adjust. Now keep the pointer on point M. Okay, and just make arc on both the side of that radius which is extended out. Okay, PM is the radius and I have just extended it out of the circle so that I can make these arcs. Okay, so the pointer I kept on M, any distance I have taken on the compass, but with whatever distance I have taken to make an arc on the left hand side, same distance I'm going to just turn and make an arc on the other side. Now you can change the distance, you can make it a little bigger one, slight, or you can have it as it was. Keep the pointer on one arc. Okay, these two arcs which we have made first initially. Now I'll keep the pointer on one arc. Okay, and now I'll make a arc at the top and bottom. Okay, I'll keep the pointer on one arc. I'll make an arc at the top and bottom. Okay, now with the same distance, now I'm not going to change the distance. Once I keep the pointer here and make an arc up and down, now I will not change the distance. I'll keep the pointer on the other arc and I will just cut this arc. Try to hold the compass here at the end so that it becomes easier. If you want to fix the pencil, you can just slightly hold the pencil part. Otherwise, try to hold the compass at towards the end. Okay, and just to move the pencil, if it is not moving, you can just slightly hold it to move, to balance it. Okay, now we have got arcs, intersection of the arc at the top, intersection of the arc at the bottom. We just have to join with the line and it will pass through that point M. Okay, we make sure it passes through the, yes. So this is actually, we have drawn a perpendicular, but since we have drawn a perpendicular which is passing through this point of radius, it becomes a tangent. The property we have already studied in chapter 3 circle. Okay, so you can see the analytical figure and the figure here. So this is ready. A tangent passing through point M to a circle with center P. Now the second sum here is for homework because it is exactly the same as the first sum. Draw a circle of radius 2.7 centimeter. The radius earlier was 3.2. Now we have to take the radius 2.7 and draw a circle. The name of the center is not given. You all have to take any letter as a center. Draw a tangent to the circle at any point on it. Again, they have not given the name of the point. So you can label it any alphabet and take a point anywhere on the circle, but I said preferably it is good if you place it on the right hand side of the circle. So here, since second sum, no alphabets are given for the center and the point on it. It is your choice, but do take some alphabet, name it, name the circle with center and name the point. Okay, so the second one is for homework. Now we proceed to the third one. Draw a circle of radius 3.6 centimeter. Draw a tangent to the circle at any point on it without using the center. Now this is the second type what I told you. First we used the center. Now you will say, how did we use the center? So I will show you the first one what we did. But the second one, the second sum, what we are going to do, we are going to draw a tangent to the circle, but we are not going to use the center. Here I am just showing you the first construction what we did. When we had to draw this tangent, we used the radius. We used the center. From center we have drawn the radius and then we have extended, and with the help of that we have drawn the radius. Okay, now the next sum, the third sum, the second type what we are going to construct is using we are going to construct a tangent, or we are going to draw a tangent to the circle without using the center. Okay. Now I have already done the analytical figure here. Now in the analytical figure you will see that I have drawn a circle. Okay. And I have drawn this triangle. Okay. So in this procedure where we are not using the center of the circle, what we have to do is we have to draw a circle. Then we have to take these points on the circle where we can draw the triangle. Okay, and we are going to construct a tangent at any one of the vertex. Okay, now this property is already there in chapter 3 on page number 76. But since this year that topic which is there in that lesson is omitted, but I will just remind you, you all can go back to page number 76 of the textbook, and there is an alternative statement given for the circle theorem, that is the angle between a tangent of a circle and a chord drawn from the point of contact is congruent to the angle inscribed in the arc opposite to the arc intercepted by the angle. Okay, so the angle between the tangent, you can see this is a tangent, and the chord. So which is the angle between the tangent and the chord? This angle. This angle is congruent to the angle which is inscribed. Okay, you can see this is the inscribed angle in the arc opposite to the arc intercepted by that angle. So this is the angle and this is the arc which is intercepted by this angle. Okay, so which is that opposite arc? This arc left over here. In that arc, this angle is intercepted. Okay, so according to that theorem, according to that property which is there on page number 76, this angle here is congruent to this inscribed angle. This property we are going to use here where we don't have to use the center of the circle. Okay, so we just proceed. First we need to draw a circle. Okay, so I take the compass. Now the radius of this circle is 3.6 centimeter. So we can just show it here. .6 centimeter is the radius. So what we do is on the compass we will take 3.6 centimeter and first we will draw the circle. This is a circle here. Okay, this is a circle with 3.6 centimeter. Now, as we are going to use this property that the chord of the circle and the tangent, this angle is congruent to the angle which is inscribed in the arc which is opposite to the intercepted arc. Now for this angle, this arc is intercepted. Which is the left one arc? This arc is left. So this is the angle which is intercepted. So this angle is congruent to this angle. This property we are going to use. For that first we need a triangle. So we will take any 3 points. Any 3 points we will mark on the. So this is a circle and I have marked any 3 points. These 3 points I'll just join to form a triangle. There is no measurement that what measure or what length should be the side of the triangle. You take any 3 points on the circle and we just have to join. Now if I consider this point and I have to draw a tangent at this point, therefore I have to draw an angle which is congruent to this angle over here. Is it clear? So we will proceed. We have to use the steps what we use to draw congruent angles. So I have to draw a congruent angle to this over here at this vertex. Okay, so any distance, I keep the pointer here and I just make a arc. Same distance, I just keep it here and I just make an arc. Try to make a little bigger arc. Now I just count this distance. I will just count this distance from this point to this point here where I have marked the arc. Okay. Yeah, and this distance I will just keep on this base line here where it is cutting. The arc is cutting that line. I'll keep the pointer there and I will just cut the bigger arc what I've made. Okay, so now this point and this particular point I'll try to join, and whatever line I get, whichever line I get, that is the tangent to this circle. So this is the method which is used without using the center. We draw a circle of the given radius, then we take any 3 points on the circle to form a triangle. Okay, it is not necessary we have to draw the tangent at this particular vertex only. We can also draw a tangent at this vertex or this vertex. Okay, so in that case, the congruent angles will change. So if we are drawing the tangent at this vertex, okay, so we are going to take the congruent angle of this. Okay, so the tangent will come here. So this angle is congruent to this angle over here. So you have to take the congruency of this angle here. Okay, so this is the third sum what is completed. Now we look at the fourth sum. We draw a circle of radius 3.3 cm. We draw a chord PQ of length 6.6 cm. Draw tangents to the circle at point P and Q. Write your observation about the tangents. Okay. Now I have already done the analytical figure. Now you will see here I have drawn a circle. I have shown the radius as 3.3 cm. We have to draw the chord. But you will see here that I have drawn a chord here which is equal to the diameter. P and Q are the points on the circle and the chord is passing through the center. Yes, because 3.3, if it is the radius, the diameter is 6.6. Diameter is double of radius. So if 3.3 plus 3.3 is 6.6. So 6.6 is the length of the chord PQ, and it is also the length of the diameter. So PQ and diameter are one and the same. And if they are one and the same, we have to draw tangents which are passing through P and Q. The drawing of the tangent method will be same as we did for sum number 1. So let's begin. We first take the compass. We adjust our compass to 3.3 because we have to draw the circle. So let me do that first. So I have adjusted my compass to 3.3. Okay. And now I'm going to draw the circle. Here. Okay. So center taken as O. Now since the radius is given 3.3 centimeter and PQ is given as 6.6 centimeter. As I said that PQ is nothing but it is equal to the diameter, the length of the diameter. Usually when we are going to mark a chord on the circle, what we do is we make arcs. That I will show you in another sum. But since it is the diameter only, that I will not take any trouble to make any arcs. I will straight away draw the diameter and I will show this as point P and show this as point Q. This will happen only when the given chord is equal to the diameter. Okay, remember this. So this is 3.3 centimeter. And PQ is 6.6 centimeter. Now in the first sum what we have done, when we have to draw the tangents at a given point. So I extend this radius outside as we had done for the first sum. No, I extend this radius outside. Same method. I'll take the compass. I'll keep the pointer on P. Okay. Make an arc on both the side. Okay. Now I can adjust, make a little bigger. I keep the pointer on this one arc. I make an arc at the top and down. With the same measure, I keep the pointer on the next arc and I just cut. and then I will just join the intersection of these two arcs, and I will see that they are passing through point P. Same method I will use for Q. I keep the pointer and I make the arcs on both the side. You know why I am keeping the pointer on Q? Because I want the tangent to pass through point Q. Now I'll take the compass, I will adjust a little, I will make an arc at the top, make an arc down. With the same measure, I place it on the other arc. I just cut the arc. Just draw it a little longer. Okay. Now they have asked us that what is your observation about the tangents. Now we know that the radius OP and this is a tangent, they are perpendicular. Radius OQ and the tangent, they are perpendicular. Okay. Now P dash O dash Q. Okay. So you will observe here, we know that O is the center of the circle. Point P and point Q lie on the diameter. So P dash O dash Q. And this is the tangent which is perpendicular to line PQ. And again this is also the tangent which is perpendicular to line PQ. Both the tangents are perpendicular to the same line. Therefore, they are parallel to each other. Okay. Or the other thing is, you can see that these two angles are 90 degree. Okay, 90 plus 90 is 180. They form the interior angles. Okay, when the interior angles are supplementary, the lines are parallel. Okay, so this tangent, if you want, you can name this as tangent L and tangent M. Please put it in here also in the analytical figure. So if we put here tangent L and tangent M, then tangent L is parallel to tangent M because you can see here that the interior angles are supplementary. This particular angle here and this particular angle are equal to 180 degree. Okay, so we need to write the answer as they have mentioned. So what we'll do is, we'll mention here at the bottom. The tangents drawn at point P and Q are parallel to each other. Clear? So we are going to construct, we'll draw the analytical figure, we'll draw the actual construction, and we're going to write this answer. Now let's look at sum number 5. Draw a circle with radius 3.4 centimeter. Draw a chord MN of length 5.7 centimeter in it. Construct the tangents at point M and N to the circle. So let's see how we are going to solve this sum. Now I have already drawn the analytical figure here. Now in the analytical figure, you will see that I have drawn a circle with the radius, given radius. Okay. Now they have said that there is a chord MN which is of length 5.7 centimeter. Okay. Now this is the sum exactly like the fourth sum. Only the difference is in the fourth sum, the chord which was given, the length was equal to the diameter. And therefore we have drawn the diameter over there. Okay, but here it is not the case. Here 5.7 is less than the diameter. So it can be placed anywhere on the circle. So what you have to do is, first you have to draw a circle. Okay, and then we have to take the measure 5.7 and then mark it on the circle. And the points of those end points of that segment or the chord should lie on the circle. And from these end points we have to construct the tangents. Okay, so we'll see how to go about. Okay, so now the first thing what we are going to do is we are going to draw a circle. For that we need a compass, and we need to the distance what we need to take here in the compass is the radius. So it is 3.4. So let me mark it. Yes, exactly 3.4 I have taken, which is the radius, and I'm going to draw a circle now. Okay, so taking this as a center, I have just drawn a circle. Clear? Now after this, what we are going to do is, we are going to see how we are going to draw this chord, which is 5.7 centimeter. So what we are going to do is, first we are going to take this compass and a scale, and the distance we are going to take it as 5.7. Okay, so here this is 5.7 exactly. Okay, now this is the distance 5.7. So what we are going to do is, since we know that the chord, okay, the end points of the chord, they lie on the circle. So what we are going to do is, we are going to keep the pointer anywhere on the circumference. Okay, so if I keep it, preferably try to keep it on the lower side. You can keep anywhere and you can draw the chord, but preferably try to keep it on the lower side so it is easier to draw the tangents. So if I keep the pointer here, I have to just cut the other side of the circle. Okay, wherever I am keeping the pointer is one point. Okay, and this, where I am making this arc, this is the other point of the, or the other end of the chord. So this is M and N. Okay, to just make sure, you can also check with the scale that whether it is 5.7. Yes, and we draw the chord. So nothing much difficult, just take 5.7 distance here on the compass with the help of the scale, and just keep the pointer anywhere on the circle. Okay, I have kept here on the lower side, and then just mark it on the circumference only. Make a arc wherever it comes. Don't adjust the compass to get the arc. You just have to take 5.7 on this. Again, I can show you. Just keep the pointer on one place. Don't adjust this distance, because this distance is 5.7. So don't adjust the compass distance. Just check on the circle where you can make a proper arc. So you can make it even here. You can see that here, even here you can make an arc. So in that case, we have to draw a chord like this. And which other place on the circle circumference? Here, which I have made. Okay, so two places I can make an arc. So you can choose any one. So I have chosen this arc. You cannot make an arc here. It will go in the center. The arc has to be made on the circumference. So either here or here. So if you make this arc, then you have to draw this chord here. But I preferred this arc. You can see here. I preferred this arc, and therefore I have drawn the chord here. Now, the next step, that is, let me mark the center. Now we have to draw the tangent passing through M and N. Okay, from a point outside. Now, always remember that when we have to construct a tangent or draw a tangent with the help of the center, from the center, we have to draw the radius up to that point, maybe this point M. Okay, so I'm just making this, joining the center to this point M, and I'm going to extend it a little more. And you all know why I'm extending, because I have to construct a tangent here. Same I will do on the other side. I will, from the center, I will draw this radius up to N, and I will extend it a little. Okay, now the same procedure what we do for constructing the tangent. So since the tangent has to pass from point M, I'll keep the pointer. I'll adjust the compass in such a way that I'm getting arcs on both the side. So I keep the pointer on M. I make an arc on one left hand side, right hand side. Okay, and now I just have to keep the pointer on one arc. I will just increase a little this distance. Now I'll make an arc up and down with the same measure. I keep the pointer here on the other arc and I just cut this arc. This procedure you have learned in the earlier standards, so this is not something new, to draw a tangent from passing through a given point. Okay, since this is a radius and this is a tangent, they are perpendicular. You can show them. Same procedure we'll follow for this other side. Keep the pointer on N, adjust the compass that you get arcs on both the sides of the N. Don't change the distance. Once you make an arc on one side, just turn it to the other side and make a other arc. Okay, now you can make a little adjustment in the compass by increasing. Now I keep the pointer on one arc and I make a arc up and down. Keep the pointer on other arc, I make a arc up and down. Okay, you can see. Now I will draw this in such a way that it passes through the, yes. Since this is a radius and a tangent, they are perpendicular. Okay, and these are the two tangents which we were told to draw passing through M and N. Now after sum number 5, we will do sum number 7, because we are not doing sum number 6 because it is for homework. Okay, sum number 6 and 7 are similar. So I'll be doing sum number 7. So exactly you can do in the same way sum number 6. Okay, 7 is draw a circle with radius 4.1 centimeter. Construct tangents to a circle from a point at a distance of 7.3 from the center. Okay, so we begin with the 7th one. I have already drawn the analytical figure. So what this figure is shown that we have drawn a circle with 4.1 as a radius. Now we have to extend this radius from the center. The distance is 7.3. So we have to take a point which is at a distance of 7.3 from the center. They have not given any letters or alphabets, so we have to take of our choice. So here I have taken O as the center, and from the center, that 7.3 centimeter, this point I have taken as P. Sorry. Now we have to draw the tangents from this point to the circle, and we have studied the property in chapter 3 circle, that there can be two tangents drawn to the same circle from a point outside the circle. So from this point P, which is outside the circle, we can draw two tangents, tangent PA and tangent PB. We have also studied one property that these tangents are congruent. So after the construction, just to verify, you can just take a scale and just measure PA and PB. They will be congruent. Okay. Now we begin. So first we need a circle. So the first step here is we have to take a circle where the radius is 4.1. So you just adjust your compass with the help of the scale to 4.1. Okay, here. Now I will draw the circle here. So you can see this is a circle. They have not given any alphabets. We can take it as 0. You can take any other letter. And they have said that we have to take a point which is at a distance of 7.3. Okay, so what you can do is directly you can hold a scale and you can mark 7.3, which is from the center. Don't make a mistake, because usually you can tend to make a mistake by counting it from here, from the circumference. No, 7.3 distance is from the center. So hold from the center, directly you can mark 7.3, or what you can do is you can directly first draw a long ray and then you can just measure 7.3 on the compass. 7.3 is here. Exactly. And now from the center, I'll keep the pointer on the center and I will make an arc of 7.3. Okay. So the other method is like this. So this is distance 7.3, which is point P I have taken. Here you can show that this distance is the radius distance and this distance is the 7.3 distance. Okay, so I'll write here 7.3 and we have taken the radius as 4.1, which is given. Okay, now we have to draw tangents to the circle which will pass through this point P. Okay, so now before that, since we want tangent passing through P, we will first draw a perpendicular of OP. What is OP? OP is that 7.3 distance. So first we will draw a perpendicular to OP. For that, keep the pointer on O. Adjust the compass in such a way that it is more than half of OP. This is OP. Wherever you have to draw the perpendicular, that segment, you have to take the compass distance which is more than half. So OP, I have to draw perpendicular. So what I'll do is, I'll keep the pointer on P and I will just check more than half. More than half is somewhere here. You can see. And I'll just make an arc up and down. Okay. Now with the same distance, I keep it on O and I just cut this arc. I'm going to just join this intersection and this intersection here. That will give me a perpendicular to OP. Okay. Now, once I get this perpendicular to OP, this point here, where the perpendicular is drawn to OP, from that point to the center of the circle, I will keep the pointer where the perpendicular and this segment they meet. So this point, okay, and I will adjust my compass so that it reaches here to the center. Okay, so taking this as the radius, I have to draw a circle. Even if you don't draw the circle, you can just make arc on the circle. Okay, if you want, you can draw a complete circle, or you can just make this arc. We just want this arc here on this, cut on the circle. So again, I'm explaining. First, we have drawn the circle with 4.1 centimeter as a radius. Then we have extended from the center. We are taking 7.3 distance. Okay, so from the center 7.3 is this point P. Okay, and then we are going to draw a perpendicular to this OP. After drawing perpendicular to this OP, this point, okay, where this perpendicular and this OP meets, that point, and we just have to take the measure up to this center and just make an arc, or you can draw the full circle also. And from this point P to this intersection, you can see this intersection of two circles, I'm going to draw the tangent. Okay, so this is tangent PA and this is tangent PB. Okay, which we have drawn. Now if you can measure, you measure and you will see that the distance is same. Okay, this is 6. Let me check. Yeah, this is also 6 centimeters. So the measure of the tangent. Sometimes you get a question that write the length of the tangent. So here we can just take the length of the tangent, and both the tangents' lengths should be same, which is equal to 6 centimeter here in this sum. Okay, now similar sum we have in, you can check sum number 6. Draw a circle with center P and radius 3.4 centimeter. Here they have given the alphabets. So you can take the same alphabets, and you have to take the same alphabets. If they have given the alphabets or the letters, the labelings, we have to take those labelings only. So center P, draw the circle, first step with 3.4 as a radius. Then we have to, from the center, we have to take the length or the distance 5.5 centimeter. Okay. In the 7th sum, we have taken 7.3. So, in the 6th sum, from the center, take the distance 5.5 centimeter, make a arc. That will be point Q. And from that point Q, we have to draw the tangents. So, the next procedure will be the same. Once you get point Q, same procedure what we have done for the sum number 7. Once you get this point, you just have to draw a perpendicular to the segment. In the 6th sum it is 5.5. Once you draw the perpendicular, this intersection where the perpendicular and that segment meets, from there adjust the compass till the center of the circle and draw a circle. When this circle intersects the first circle, those points are the points where you will draw the tangent from the point outside. So PA and clear. With this we finish with 4.2 exercise. So here in this 4.2 I have given 2 homeworks. That is sum number 2 is for homework and sum number 6 is for homework. Okay. Also you are going to solve the sums from the problem set 4, which are similar to the sums in 4.1 and 4.2.
Students, complete the sums from practice set 4.1, 4.2 and problem set 4 in your notebook. Thank you and have a nice day.